Hey everyone, welcome back to my channel. In this video, we will be discussing the topic quantum computing. What makes quantum computer different? How do they work? Can we use them today? Introduction to quantum computing. Quantum computing is a revolutionary field that merges physics, computer science, and mathematics. Unlike classical computer that rely on bits, zeros, and ones, quantum computing uses qubits, which leverage the strange principle of quantum computing. Why is this important? Because quantum computers can solve problems that classical computers would take thousands or even millions of years to compute. Now, let's discuss the topic fundamental of mechanism, superposition. Imagine a traditional bit as a coin with two sides, heads for 0 and tails for 1. A bit, on the other hand, is like spinning coin, existing in both states at the same time. This means quantum computer can process multiple possibilities at once, massively increasing computing power. Entanglement. Entanglement is a mysterious connection between qubits. If two qubits are entangled, changing one will instantly affect the other, even if they are light years apart. This allows quantum computer to perform calculation in a way classical computers simply can't. In this slide, it presents how qubit works, and in this slide, superposition, it is based on Young's double slit experiment. When one particle passes through a double slit, it behaves as a wave and passes through both slits simultaneously. It is present at two different positions at the same time. Here, it shows how entanglement works. First, there are two qubits, then it links to each other. In entanglement, it links and entangles two or more bits to share information to each other. Now we will see classical computing vs quantum computing. So in classical computing uses bits 0 and 1, relies on logic gates like AND or NOT, performs calculations sequentially or through limited parallelism. But in quantum computing it uses qubits 1 or 0 or both at once, operates with quantum gates that manipulates probabilities, processes multiple possibilities simultaneously. The challenge: quantum computers are highly sensitive to interference, making them difficult to build and operate reliably. Now discuss next slide. Quantum algorithm. First is Shor's algorithm. This algorithm can break RSA encryption by efficiently factoring large numbers, posing a serious challenge to modern cryptography. Now, Groover's algorithm need to search through amounts of data. Groover's algorithm can speed up search task dramatically. Quantum simulation. Quantum computer can simulate complex molecules, helping in drug discovery and material science, leading to major advancements in medical and technology. Now, now we will discuss the topic quantum hardware. How do we build a quantum computer? Superconducting qubits made from superconducting materials and kept at near absolute zero temperature. These qubits process information at high speeds but are sensitive to noise. Trapped ions. Atoms are held in place with lasers, offering high accuracy but operating slower than superconducting qubits. Neutral atoms. These use laser beams to arrange atoms, showing promise for scalability and stability in large scale quantum computing. Now we will see next slide. Quantum cryptography, unhackable security. Quantum key distribution, QKD. This technology allows two parties to share encrypted messages using quantum properties. If a hacker tries to intercept the data, the quantum state changes, alerting the users. Unbreakable encryption. As quantum computers advance, classical encryption methods may become obsolete. Quantum cryptography will be essential for security future communications. Real world application of quantum computing. Drug discovery. Pharmaceutical companies can use quantum simulations to develop new medicines faster and more efficiently. Finance and risk management. Quantum computer optimize investment strategies, helping banks and financial institutions analyze risk and predict market trends. Material science. Designing stronger, lighter, and more efficient materials for industries like aerospace and electronics. Artificial intelligence and machine learning. Quantum computing could accelerate AI, making future self a learning algorithm faster and smarter. Now we will discuss challenges and limitation. Noise and decoherence. Qubits are extremely sensitive to their environment, which can cause errors in calculation. Scalability. Building large stable quantum computers with thousands of qubits is still a massive challenge. Algorithm development. While classical computing has thousands of algorithms, quantum computing still lacks a large collection of practical algorithms. So thank you for watching my video.